Hello guys, so today we are going to be talking about chemical kinetics. So when we talk about chemical kinetics, what are we talking about? Chemical kinetics is actually the study of rate of chemical reaction, and rate of chemical reaction is the rate at which the reactant disappear and the rate at which product appears. That is what we mean by rate of chemical reaction. So let's say we have a reaction like this: A plus B to give us C. Good. So now our rate will actually be equal to minus the A over the T, which is actually also equal to minus the B over the T, and is equals to the C over the T. Nice. So don't forget that we define rate of chemical reaction as the rate of as the rate of disappearance of A with respect to time, or the rate of disappearance of B with respect to time, and the rate of appearance of C with respect to what? To time. That is the rate of chemical reaction, because A and B here are what? Are reactants. Now, why are we having a negative sign here? Let's explain the reason. Now, don't forget that as we are carrying out the reaction, A will be disappearing, B will also be disappearing. Only C will be appearing, because C is what? The product. Now, let's assume that the concentration of A I started with is 5 molar. That's my initial concentration. And at the end of the reaction, if the reaction is visible, I can be having what? 2 molar as my final. Now, my change in A, that is change the concentration of A, don't forget it will be concentration, the final concentration minus what? My initial concentration. So my final concentration that I got here was what? 2 minus what? 5. So I'm going to have what? Minus 3 as my answer. Our rate can never be negative. So to counterbalance this negative sign, we have to put a negative sign here. The same explanation goes with this. But our C will be positive. Why? Because C will be appearing. The concentration of C will continue to what? To increase. So if I started with 2 as my product, the initial product, my final product will be more than 2. So at the end of the day, my change will be a positive change. Shall we get that point? So that's it. Now, let's now move to some other part of this particular part. Now, let's say the reaction A plus B to give us C. When we now balance it, we are having small letter A as the number of mole of this, small letter B and small letter C. Our rate now will be equal to minus 1 over A, the A over what? The T, and is equals to minus 1 over B. We have what? The B over what? The T, and that's also equals to what? 1 over C, the C over what? Over the T. So let's take note. Now, how do we use this formula? Let's see a question like this. Let's say there's a question that says find the rate of disappearance of ammonia, the rate of disappearance of hydrogen gas. Let's do that. Hydrogen gas in the production of ammonia if the rate of appearance of ammonia is 1.42 times 10 raised to power minus 3 molar per second. Okay, now this is what they gave us. Now let's write this reaction. When we want to form ammonia, production of ammonia, it is actually N2 plus H2 to give us NH3. So let's balance this reaction. To balance this reaction, I think I have to put 2 here. If I put 2 here, I'll just add 3 here. Very good. So I think this reaction is balanced. So this is what we are having here. Now, the production of ammonia, we get this. Now, what did they ask us to find? They say we should look for the rate of disappearance of H. That means the rate of disappearance of it, they asked us to look for the H, the H2, over what? Over dt. That's the question. Now they give us the rate of appearance of NH3, that is the NH3 over dt. They give us to be equals to what? 1.42 times 10 raised to power minus 3. Okay, good. Now don't forget, if I want to write this particular reaction like this, I will say okay, my rate will be equal to minus 1 over 1, since we have invisible 1 here, minus 1 over 1 dn2 over dt, and that will also be equal to minus 1 over 3, since I'm having 3 here, dh2 over dt, and it will also be equal to what? 1 over 2 dnh3 over what? Over dt. So this is what I'll be having. Now what they asked me to find in this question now, they asked me to find the H2 over dt, the rate of disappearance of H2, that is hydrogen gas. This is it, and then they gave me this. So I can relate these two formulas together. So I can say okay, 1 over 3 dH2 over dt will be equal to 1 over 2 dNH3 over what? Over dt. Now you will notice that I did not put this minus here. Why? Because don't forget, the reason why we put that minus there is because if you're having a minus sign, we want to counterbalance the minus. Since there is no minus sign, there is no need for us to put any negative sign. So we continue. So we have 1 over 3 dH2 over dt to be equal to 1 over 2 to multiply. This is actually 1.42 times 10 raised to power minus what? Minus 3. So we have 1 over 3, we have the H2 over dt now to be equal to, now if I should solve this using a calculator, we have 1.42 divided by 2, that should give us 0.71 times 10 raised to power minus 3. Now I'm looking for the H2 over dt. So to cancel this, I multiply all through by 3. So 3 times 1 over 3 dH2 over dt will be equal to 3 times 0.71 times 10 raised to power minus 3. Good. Times 10 raised to power minus 3. So good. Now 3 will cancel out this 3. Sorry. So we have dH2 over dt now to be equal to, if I multiply this by 3, so I will have 2.13 times 10 raised to power minus 3 molar per seconds. So that's my answer. You can see what we can use this first formula we got here to do. Okay, so let's move on to the next point. Now let's talk about rate law. Now what does rate law talk about? Rate law says that the rate of reaction is directly proportional to the concentration of the reactant. So this is rate law. Rate law says the rate of reaction is directly proportional to what? To the concentration of reactant raised to power the order of that reaction. Now if we change this into equal to sign, we are going to have our arrow to be equal to a raised to power n. Now we should not forget that our arrow here is for rate of reaction. We're talking about rate of reaction. And okay, sorry, when we change this into equal to sign, we are going to introduce a constant k. We should not forget. So our k here is actually referred to as rate constant. Refer it to as rate constant. And then our a here is what? The concentration of reactant. Concentration of reactant. And then our n is what? Order of reaction. Order of reaction. Now this order of reaction is not gotten from the overall equation or the balance equation. It is gotten experimentally. That is why our n can be in fractional form. It can be 1, it can be 0, but it can never be a negative sign. These values for n. So our n can be fractional form. It can be 1 over 2, it can be 1 over 3, depending on the value that we got. And it can be 1, it can be 0, it can be 2, and so on, but it can never be what? Negative. Do we get that point? Now let's check out the SI unit for our K. Since our R is actually equal to K, and we have A raised to power what? N. Since this is what we have, our SI unit for K will vary, depends on the value of N that we get. So value of N determines the SI unit of what? Of K. So don't forget our rate of reaction is measured in what? In molar per seconds. And then we have our K. Our concentration is also measured in molar raised to power what? Raised to power N. So then we are going to have our K now to be equal to m per seconds divided by what? M raised to power what? N. If I divide both sides by what? By m raised to power n. Just to make this K the separator of the formula. So at the end of the day, I'm going to have my K to be equal to m. This is raised to power 1, this is n. Since this is divided, it turns to what? A negative sign, n per what? Seconds. So this is actually the general formula for like the general SI unit for K, depending on the what? The value for n. So let's say our n is 0, which is the least or the smallest value we can get. Actually, we can actually get fraction 1 over 2 too, but let's say let's talk about zeroth order. So if our order is zeroth, so we are going to have our SI unit for K now. Our SI unit for K now. So sorry about this. So our SI unit for K will be equal to m raised to power 1 minus 0 over what? Seconds. So this will be molar per what? Seconds. That's for K. That's for when our n is equals to 0. When n is equals to 1, we are going to have our K to be equal to what? Molar raised to power 1 minus 1 over what? Seconds. And this is m raised to power 0 over what? Seconds. And that will give us what? 1 over what? S. So it will be per seconds for first order reaction if our n is equals to 1. Now if our n is equals to 2, that is if our order of reaction is equals to 2, then our K now will actually be equal to m raised to power 1 minus 2 over S. So we are going to have per molar seconds. So this is 1 over molar seconds, or in other way, per molar per seconds for second order reaction. So and so on and so forth. So that's how we get the SI unit for what? For K. Now don't forget that this m start for molar, and we can also actually refer it as what? Mole per dm cube. So if I replace this thing by mole per dm cube, I can say my K from here. Let's say we have this now. Can say okay, my K will be equal to mole per dm cube per seconds. That's for zeroth order. For my first order here, I can also say that my K is actually equal to still per second, since it does not depend on the concentration. And for second order, since I'm having this, it's actually going to be my K to be equal to dm cube per mole per seconds. So check out. So these are the SI unit for K. You should check out. So, okay. So now, what about how concentration affects rate of chemical reaction? So we should not forget that rate of chemical reaction is directly proportional to concentration. So if we increase concentration, the rate of chemical reaction is what? Is increased. Now let's check out some questions under this one by one. So we wrote our weight law as this, but don't forget that if we have maybe two reactants like this, sorry please to give us C plus D, our weight law will be written as RE to be equals to K open bracket A raised to power N and B raised to power what? M, because it's directly proportional to the concentration of the reactant. It can be more than one reactant. So if we write it like this, that means the only reactant we're having is A, and here we're having A and B as our what? Major reactant. Now this A and sorry, this will be M. M and N might be different. Our A can be half, our N can be half, M2 can be also be half, our N can be 1, this can be 2, so it depends. Do you understand? Okay, good. Now let's see. Let's work with these two. So let's imagine that we got our n to be equals to 1 and our m to be equals to 2. Our overall order reaction of reaction will be n plus what m, which is equals to what 1 plus what 2, and that is give us what 3. So that's the how to get the overall order. The addition of the order of each reactant order will give us the what the overall order. So now let's imagine that we also have this to be 1 and this to be 2. That means our R now will be equals to Ka and B raised to power what 2. Nice. Now if we increase the concentration of B by a factor of 2, that means we increase it from AO is equals to, let's say our AO is normal concentration of B, and then the final we now increase it to be equal to 2B. What will happen to the rate of chemical reaction? Let's see. Since it is B that we increase, now let's call this one our R1. Our R1, this is our A naught, and let's say our A naught is still equal to A final. A naught is equals to A final. That means our concentration of A remain constant. It is B that we increase by what? By B2. Do you understand? So it's equals to 2 times B or not. Now what do we do next? Our RF, that means our final rate of chemical reaction will be equal to K. We have A naught. This is our A naught. AF is AF, good, and then it will be BF, right? So since we are talking about final, now we have our ROF to be equal to K. Our AF is still what? A naught, right? So it is A naught. We want to write it in terms of A naught. And then our BF, what's our BF? 2B naught. So it is 2. Just don't forget this raised to power 2 from the question. This is 2B naught raised to power 2. So at the end of the day, I'm going to have my ROF to be equal to K. This is A naught. And if this 2 raised to power 2 give us what? 4. So I can bring the 4 out. I can say okay 4, and then we have B naught raised to power what? 2. Very good. Now bringing the 4 out, you can have our ROF to be equal to 4K A naught and what? B naught. So what is this talking about? Now don't forget that this K A naught B naught is still what we have here. This is B naught too. This is what we have here. So I can replace it as my what? R1. So my ROF now will be equal to what? 4 to multiply what? R1. So my ROF is equals to what? 4 R1. So if I should increase the concentration of a second order reactant by a factor of 2, my rate of chemical reaction, will be increased also by a factor of what? 4. It will be raised to power of that 2. Do you understand? So that's it. But assuming it is A, let's try A. Let's say A is one that we increase by a factor of 2. What are we going to get? So let's say our B naught remain constant. That means our BF is still as final concentration of B is still same thing as our initial concentration of B. And then I say okay, my AF, that is final concentration of F, is equals to 2 to multiply the initial concentration. Now don't forget that my RF now will be equal to KAF, and then my BF to raised to power 2. So then my RF will be equal to, don't forget I'm still working with this is what I'm still working with, my K. Now my AF, let's say we increase by a factor of 2, so it will be 2A naught, and my BF same times my B naught, so it is B naught square. I can bring out these two, so my RF is equals to 2K A naught and what? B naught square. So K A naught B naught is still the same thing as what? R1. So my final reactant and my final rate of chemical reaction will be 2R1. So you can see if I increase the concentration of a first order reactant by a factor of 2, the rate of chemical reaction to be increased by a factor of what? 2. But if it's second order that I increase by 2, my rate of chemical reaction will be increased by a factor of what? 4. We should take note, very very important. But if it's zero order, don't forget, assuming we have R is equals to Ka raised to power 0. So A raised to power 0 means our R is equals to what? K. So no matter what I increase the concentration by, it will not affect the rate of chemical reaction because it is independent of the concentration. Zero order will not, well, no matter what we did to the concentration of a zero order reaction, the rate of chemical reaction remain constant because it is just depending on the what? The constant, which is what? Which is K. So take note. So that's it. So let's take note of this. The next part we are going to be looking at now is how we can generate some other formula for first, second and third order reaction. Check out our next video for that. So now let's look at this particular question. They gave us this equation and they asked us to find the order of each of the reactants one by one. So they give us reactant. This is propanol. They give us propanol. They give us alcohol. So this is propanol. They give us ethanol and they give us H plus. Good. So they give us each of these reactants and they want us to get the order of each of the reactants. We can only get the order since they give us different concentration and the rate of each of the reaction at each particular concentration. So they give us the rates at all this particular concentration and so on and so forth. Good. Now using rate law says that the rate of chemical reaction is directly proportional to the concentration of each of the reactant raised to power their order, and this is what we have been able to derive. Since we have our R to be equals to the rate constant, the concentration of this is ethanol raised to power the order, let's say the order is A, and the concentration of alcohol, which is ethanol, raised to power the concentration, and the concentration of what? H plus raised to power the order to which is C. So we want to get the value for A, B and C. We can get them one after the order. Now let's start from A. To get the concentration of A, we are going to look at, to get the value for A please, we are going to look at the concentration of propanol. Propanol is C2H5CHO, the one that are different, and then the concentration of C2H5OH and H plus should be the same if I want to look for A. So if C2H5 for the two I'm picking, because I'm going to pick two values from here, let's say I pick value A and value B. So the two values I'm picking out of those two values, the only one that should be different is the one of propanol. The others will be the same, so that we can understand what I'm talking about. Let's look at the first one. We have the first value they give us 0.2, they give us 0.1, they give us 0.05 and they give us 1. The second value was 0.25, 0.1, 0.05 and 1. So you can see that the concentration value for ethanol and H plus are the same, but the concentration of propanol is different. So we can actually use this to get the value of A. How? Let's look at it. Our R for the first, so let's call this one equation 1, this 2, so it can be easy for us to identify. This 3 and this is 4. Good. So let's start from 1. From 1 now, our R is equals to 1, so we can say 1 is equals to, we don't know value for Q, which is a constant value. C2H5CHO, our concentration that they give us for equation 1 is 0.2. Don't forget that it is raised to power A, right? Good. And then the concentration of C2H5OH, that is ethanol, is 0.1 according to equation 1, and the concentration of H plus is 0.05. This is raised to power B, this is raised to power C. We shouldn't forget. So let's call this equation 1. And then for equation 2, our concentration they give us is 1.25. So we have 1.25 is also equals to K. We are still using this particular equation. Please take note. We are following this particular equation. That's what we are following. So K open bracket. The concentration of C2H5CHO for the second values they give us is 0.25. So we have 0.25 followed by 0.12. Don't forget this is raised to power A, this is raised to power B, and the last one is 0.05 to raised to power what? Raised to power C. Let's call this equation 2. Now divide, sorry, this is, so okay, let me change this, sorry. Good. Okay, good. So divide equation 2 by equation 1. So divide that. We want to divide equation 2 by equation 1. So our equation 2 is 1.25 to be equal to k open bracket 0.25 raised to power a and 0.1 raised to power b and 0.05 raised to power c divided by equation 1. What we have for equation 1 is 1. O is equals to 2 over, so don't forget that we are dividing by over, we have k, we have 0.2 raised to power a, we have 0.1 raised to power b, and we have 0.05 raised to power what? C. So with this now, 1.25 divided by 1 will give us 1.25. Don't forget that. So we have 1.25. Okay, let's try it here. So we have 1.25 to be equal to k, we cancel out k. 0.1 b raised to power b, 0.1 raised to power b, we also cancel out. 0.05 raised to power c and 0. Also what? Cancel out. The only thing we are going to have is 0.25 raised to power a divided by 0.2. So since they are having the same power, we can just divide what we have in. So 0.25 divided by 0.2. If we try that very well, we are going to have 1.25. Don't forget it's raised to power what? Raised to power a. We have this one to raised to power 1. So you can see our a is actually equal to what? Equal to 1. You can see that we have actually looked for the value of what? The value for a. Good. Now let's move on to the next one, how to get the value for b. So how do we get value for b? We are still going to use the same method. Now, since we are looking for value for b, we are going to check out all the concentration they gave us. We are picking the one that is different for the value of ethanol. Do we get? So we are picking a value that is different for ethanol, but the words that we are choosing must have the same. Why must they have the same? Because they have to cancel out for us to get that value for what? Value for b. We are still using our major equation. This is the equation we are using. Rho is equals to k propanal raised to power 2, ethanol and propanal raised to power a, ethanol raised to power b, and h plus raised to power what? C. Good. Now we have our arrow. So which one are we going to pick? Let's look at it. We have equation 1, equation 2, equation 3, equation 4. If you're having it in mind that we should pick equation 2 and equation 3, then you are absolutely correct. Why are we picking 2 and 3? Because the concentration for ethanol for both of them are different. While the concentration for this and this is the same, this and this is the same, so they can easily cancel out. Then we can actually look for our value for what? B. So let's follow up. Now we have for equation 2, let's start with equation 2. For equation 2, we have our arrow to be equal to 1.25. So we have 1.25 is equals to k, we should not forget our k open bracket. The concentration of propanal for equation 2 is 0.25. So I have 0.25 raised to power a, we should not forget. And the concentration of ethanol is 0.1 raised to power b, we shouldn't forget. And the concentration of h is 0.05. That's equation 2. Now the equation 3. For equation 3, let me put the and equation 3. That's what we are looking at. For equation 3, we have our rate. Our rate that they gave us here is 2. So we have 2.00 is equals to, don't forget your k. We are still following this our major equation. We shouldn't forget k open bracket. Our a, the concentration for propanal for equation 3 is also 0.25. So that's 0.25 raised to power a. And the concentration for ethanol here is 0.16. Good. We have 0.16 raised to power b. And then for that of h plus is still 0.05. Please permit me, this is raised to power c, raised to power c. So we can now divide. You can just say, okay, this is equation 3. And say divide equation 3 by equation 2. So how do we do that? So that's very easy. Just say 2 divided by, since equation 3 is 2 equal to, let me put it this way, 0.25 raised to power a and 0.16 raised to power b and 0.05 raised to power c, divided by equation 1 is equation 2, which is 1.25, divided by k open bracket 0.252 raised to power a then this divided by 0.01, sorry, 0.1, no, 0.01. Good. What we have there is 0.1. So good. So I have 0.1 raised to power b, and then for c is 0.05 raised to power what? C. So this cancel out, this k cancel k, 0.25 raised to power a will cancel 0.25 raised to power a, 0.05 raised to power c, we also cancel 0.05 raised to power c. So 2 divided by 1.25, so 2 divided by 1.25, we're actually going to get 1.6. So we have 1.6 here is equals to, now 0.16 also divided by 0.1 will give us 1.62. so we have 1.6. don't forget they are both having power of b, so everything will be raised to power what? B, and this is raised to power what? 1. This cancel out this, so our b2 is also equal to what? Is also equal to 1. So we have gotten a, we have gotten b. Looking for c will be very easy to see, using the same method that we just used. So let's look for c. Okay, so let's use equation 3 and 4. Using equation 3 and 4, using the same particular formula to our major formula here. Let me just take it again so we can know the formula we are using. Now our r for equation 3 still remains 2. So we have 2 to be equal to k open bracket, the concentration we have is 0.25 raised to power a, and then we have 0.16 raised to power b, followed by 0.05 raised to power c. Good. And the other one here we are having for equation 4 is 3.20 is equals to k open bracket 0.2 raised to power a. Good. And then we have 0.16 raised to power b, and then we have 0.1 raised to power what? C. This is equation 3 and this is equation what? 4. So we can just say divide equation 4 by 3. So let's divide equation 4 by equation 3. Let's try to rub off some parts here so we can be able to solve. I'll not rub off this formula because we are still using our formula. Good. Okay, so we shouldn't forget that once you can write out your rate law and then picking out the right values to get our answer will be kind of very easy. Okay, and we should not forget that this last equation, you will notice that if you are following up, you notice that the only one we cancel, we are still going to have 2 of them that will still be there. Why it will be very easy for us to solve this way is because we have gotten all the values for the order of each of the constants or each of the reactants. So we have gotten 2 of it out of 3 that we are looking for. So if one cancel, even though we are having 2 left, you can just use the values that we have for 1 already and then use it to solve the other one, so that we can understand what we are saying. Let's get there. Good. Okay, using 3. Good. Okay, so if I say divide equation 4 by equation 3, we are going to have 3.20 divided by 2. Good. It will be equal to k open bracket 0.2a followed by 1.6, sorry, we have 0.16b raised to power b, 0.1c, all divided by k 0.25a followed by we have 0.16b, and then we have 0.05. Good. Okay, I think there's no mix up there. Good, exactly, raised to power what? C. Okay, now let's move on. What do we do here? So our k cancel out k, 0.16 raised to power b also cancel out 0. Good. So we are going to have you can see that we are having 2 left, don't forget. So we are going to have 3.2 divided by 2, that give us 1.6. okay, so we have 1.6 to be equal to, now 0.2 divided by 0.25, we have 0.8 here. Good. So we have 0.8 raised to power a. Good. Open your bracket. We have 0.1 divided by 0.05. That gave us 2. So we have 2 raised to power what? C. Don't forget that we have 1.6 is equals to 0.8. 0.8 raised to power a. The value for a we have is what? 1. So we raised to power 1. And then we have 2 raised to power c. So we can have 2 raised to power c to be equal to 1.6 divided by 0.8. Good. Divided by 0.8, sorry. Nice. So that we can get what we are saying very well. Let me explain how we got that. Good. Okay, nice. So I just divide all through by 0.8. Divide all through by 0.8. So this cancel out this. So I'm going to have 1.6 divided by 0.8. 1.6 divided by 0.8 will give me 2. So we have 2 is equals to 2 raised to power c. Don't forget that this is actually raised to power 1. So 2 cancel out 2. We have c 2 to be equals to what? 1. So don't forget that we have our a to be equals to 1, b equals to 1, and c is equals to 1. For this particular question, there are some questions that we are going to have different values for it. So don't just assume that since you have gotten 1, every other thing will be 1. No, they can be different order. We can have a to be 1, b to be 2, and even you can actually even have half, since we are talking about order of chemical reaction, not molecularity. Do you understand? So that's the point. So our overall order here, our overall order will be the addition of what? A plus b plus what? C. And that is equals to what? 1 plus 1 plus 1, which is equals to what? 3. So the overall order of this reaction is what? Is 3. So let's take notes. So be free to go back and check this kind of questions. So we're going to drop our videos on the next one, how we can solve questions on half-life and how we can integrate some of the questions we have gotten. Thank you so much for watching.